Assalamualaikum and a very good morning, Doctor. If you are seeing this video in the morning, so it is good morning. So we are doing Project 6, Influence of the Replacement Policy Towards Cash Misrate. So I am the group leader, Muhammad Fauzi bin Sahrani, and the other two members is Muhammad Haneef and Wei Han. As you can see in the slide, this is the configuration that had been assigned to us in order to run the S&P Cash Simulator.
Okay, now we are going to for the demonstration of our or the simulation test for our project. Okay, first we need to open the SMB cache. Okay, now we going to see the code development for our project. Now we are going to set for the multiprocessor, main memory, and the cache. Okay, we see back the processor in SMP equal to 1. So we must set it to SMP, then set it to 1. Okay, next the protocol must be in MESI. So MESI. Then the bus arbitration is going to be random. So set it to random. Okay, now for the worldwide bit, it must be in 16. So okay. And then the words by block is 16. Okay, here 16. Okay, now the block size must be equal to 32 bytes. Okay, 32 bytes. Okay, and next the blocks in main memory is equal to 8192. So we are going to decrease it until it's going to be like this. And the main memory size must be to 256 kilobytes. Okay, for the caches, the blocks in cache is must be 128. Okay, and then the mapping is set associative, and the cache sets equal to 16. And then this replacement policy we must go to into all four of these. So first we are going to do the random first. Okay, and then okay. Then next open the memory traces and PRG. Okay, here for our project we are only going to do NASA 7, MDLJD, and of lastly SWM. Okay, first for the NASA 7, just click it and then tick it right here. Don't touch anything that not necessary. Just stay at the one at the number of processor 1. Okay, next we type OK. And then if we will go now, we are going to do the demo. Okay, first for the multiprocessor, we are going to see the hit miss. Okay, so we go to hit miss and then set it to complete, and then just execute, and the actual access will be moving like this until it will be like this. Okay, we just wait here and until it going to the end. Okay, we just wait. Okay, after the process is ended, we must collect the hit rate, the miss rate here. So and then we just put the data in our table, just like and collect the data. Okay, the process is done. Yes, just ignore this and take the data here, 16.496%. Okay, um, it's the same for the cache and also for the memory block. Hit miss, complete, and execute. Okay, after we done all of that, we open the memory traces and change it to other other traces that we need to test, such as for my project we are going to the MDLGD. Okay, and then don't change anything in this, just stay like this, or okay first and stay for the random. And after we done all for the random, we we are going to change it to LRU, and then change the memory traces uh, every time you change of this also. Okay, that's all. Thank you.
Moving on to the simulation test, we display the table of miss rate of multiprocessor evolution. As you can see, random replacement policy has the highest miss rate compared to other replacement policies such as LRU, FIFO, and LFU. For the miss rate cache evolution, we have the exact same data as the previous table. So I am not going to talk much about this table and graph. Okay, so
Miss rate of
for
memory
this
block
slide,
evolution. As you
we
can see
found
here,
something
the
different
data
about the
in the
data,
table is quite
and we
different
display
from the
the miss
previous
rate
two
of
tables,
memory block
and
evolution
according to
on
the
the
graph
slide.
that
As we can see,
has
for
been used to
NASA 7,
analyze
for all
the
4
data from the
replacement
table, we can
policies,
see that
we
for
get
NASA 7,
0%,
we
and for
have constant
MDLJD we
value,
get
which is 0, and for
33.333%,
SWM
except
also
for
constant
LFU, which
value
is
with 33.333%.
66.667%.
But
And
we have
constant for
difference
SWM,
for LFU, because at the
33.333%
end we
for
get
all replacement policies.
66.667% of miss rate.
Hello everyone, my name is Wei Han. Today I am going to talk about the influence of the replacement policy. After the simulation test, we found that the least recently used is the best replacement policies because it has the lowest miss rate. Besides, the random is the worst replacement policies because it has the highest miss rate. As generally, we found that all policies give out the result for all the benchmark, but only data for the result on the main memory block evolution is very less because there is only small amount of access go into the main memory trace block. In this project, both least recently used and first in first out policy are independent of different locality grades because the SMP program has the same general behavior due to the same configuration except the replacement policy. We also expect the result for the different replacement policies to be different because the different replacement policies have their own function and calculation way to keep track of information. This will affect the caching performance due to occurrence of different caching results such as hit rate and miss rate. That's all for me, thank you.
Okay, for the next question, okay, does the use of concrete replacement policy improve the system performance? If the answer is yes, in general, which is the step with more benefits? From random to LRU, from random to LFU, or from random to FIFO? Why? Consider the cost or performance aspect. Okay, the answer is yes, because the performance of a high performance for of a high performance computing system is highly dependent on its cache memory. According to the data result above, the system performance can be greatly improved if the cache replacement policies that are used are gradually changed from random to LRU. This is because changing of cash replacement policy from random to LRU can greatly improve the cash performance of the system by reducing the miss rate and increasing the hit rate during catching the memory. Okay, and lastly for the conclusion, different replacement policies truly give different results to the cash miss rate. In order to maintain high cash efficiency, it must have low cash miss rate and high cash hit rate. In contrast, among the 4 replacement policies that had been tested, LRU is the best one as it conveys the lowest miss rate and causes high cash efficiency. Random replacement policy is considered the worst because it contributes to non-constant and high miss rate, which causes it to be less predictable than LRU, LFU, and FIFO. There are many software researchers that are still figuring out at the same time improving the cache efficiency with various replacement policies. This research may be beneficial to the future generation as they will continue to improve in the computer architecture field. That's all. Thank you.